Hello students, we shall discuss X-ray diffraction. You might have heard about the German physicist Röntgen. He discovered X-rays in 1895. It was so named because its nature was unknown at that time. X-rays are a form of electromagnetic radiation like light. Unlike ordinary light, these rays are invisible, but they travel in straight lines and affect photographic film in the same way as light. On the other hand, they are much more penetrating than light and could easily pass through the human body, wood, quite thick pieces of metal and other opaque objects. The basic principle behind X-ray diffraction is Bragg's law. When monochromatic X-rays impinge upon the atoms in a crystal lattice, each atom acts as a source of scattering radiation of the same wavelength. The intensity of the reflected beam at certain angles will be maximum when the path difference between the two reflected waves from two different planes is an integral multiple of lambda. Hence, the two rays will reinforce each other and produce maximum intensity if 2d sin theta is equal to n lambda, where n is equal to 1, 2, 3, etc. This equation is called Bragg's law. X-rays are produced whenever high-speed electrons from a hot tungsten filament collide with a metal target. A high accelerating voltage of 20 to 50 kV is applied between the cathode and the anode. The target is always water cooled to prevent its heating, since most of the kinetic energy of the electron is converted into heat in the target, less than 1% being transformed into X-rays. Since the windows must be vacuum tight and yet highly transparent to X-rays, they are usually made of beryllium. Discuss the Bragg's X-ray diffractometer. The essential parts of a Bragg spectrometer are a source of X-rays, a crystal held on a circular table which is graduated and provided with vernier, and a detector called ionization chamber. X-rays from an X-ray tube limited by two narrow lead slits S1 and S2 are allowed to fall upon the crystal C. The crystal is mounted on the circular table which can rotate about a vertical axis, and its position can be determined by the vernier V. The ionization chamber is connected to an electrometer to measure the ionization current. Hence, we can measure the intensity of the diffracted beam of X-rays diffracted in the direction of the ionization chamber. In practice, the crystal table is geared to the ionization chamber so that the chamber turns through 2 theta when the crystal is turned through theta. The glancing angle theta and the intensity of the diffracted beam are measured. The graph of the ionization current against glancing angle is drawn. The prominent peaks A1, A2, A3, etc. refer to the X-rays of wavelength lambda. The glancing angles theta 1, theta 2, theta 3 corresponding to the peaks A1, A2, A3 are obtained from the graph. It is found that sin theta 1 is to sin theta 2 is to sin theta 3 is equal to 1 is to 2 is to 3. B1, B2, B3 are such peaks for the first, second and third order for another wavelength lambda 2. The wavelength of the X-rays is determined using the equation 2d sin theta is equal to n lambda. Some of the applications of X-ray diffraction are to identify crystalline phases, to determine structural properties such as lattice parameters, strain, grain size, phase composition, preferred orientation, etc. to measure thickness of thin films and multilayers, to determine atomic arrangement, to image and characterize defects. For their work in determining crystal structures, William Lawrence Bragg and his father William Henry Bragg were awarded Nobel Prize in Physics in 1950. Thank you.